Ragon Institute was created to tackle big problems in global health, and that's exactly what we're doing.
So it was clear when COVID hit that the ability to culture the virus was really going to be important for understanding how COVID causes disease. So we've made the BSL-3 available to researchers at MIT, at Harvard, and at all of the affiliated hospitals.
The Ragon Institute was built on collaboration. We thrive on the opportunity to work together. When COVID hit, it was a call to action. It was an opportunity for us to extend beyond the walls of the Ragon Institute and to help bring people in, to give them the tools, and to help develop new strategies to try to combat this pathogen.
What we have done is to take that spike protein, that's what we're recombinantly expressing and giving to other individuals like Dan and Galit. And that protein is what people use to then understand the immune response. We've produced over 400 milligrams worth of these proteins and shipped to 30 to 40 different labs across the country and even across the world.
We were really fortunate to have access to the flexible funding that gave us the ability to figure out that the antibodies that are being made against SARS-CoV-2 from the vaccines might actually have problems dealing with some of the variants that have been emerging.
I thought this was a perfect example how work in HIV catalyzed our work on COVID, and I'd be able to identify mutation-resistant regions in SARS-CoV-2 to protect against variants in other SARS-like coronaviruses.
When we got details of the disease and heard about what happens to patients, that's when we saw that much of what we do can actually be applied to studying COVID-19. And COVID-19, the virus and the viral infection, actually impairs the ability of immune responses to be properly generated.
Thanks to the investment from the Ragon Institute, we have state-of-the-art infrastructure in terms of sequencing facilities and basic lab infrastructures. Thanks to this huge investment, we were able to respond in a very timely manner to this devastating COVID pandemic.
Despite all what we have done on COVID, we have not abandoned our work on HIV.
When COVID hit, we adapted our research to contribute to the fight against COVID, but we also remain committed to our original research program. We'd done a lot of work in sub-Saharan Africa showing the importance of the vaginal microbiome and HIV acquisition, and despite COVID, we were able to start a brand new trial, the first of its kind, looking at vaginal probiotics to improve the microbiome in women in South Africa to reduce their risk of HIV.
So HIV has been considered as a disease that cannot really be cured. We are trying to understand what's happening in patients who are getting long-term treatment, and we are seeing patients where we have lots of evidence that a cure might be possible.
So after analyzing more than 1.5 billion cells from these patients, we did not detect any replication-competent virus. Those data suggest that they cured HIV infection through their natural immunity without any medical interventions.
So we've been able to engineer immunity against HIV and turn white blood cells into very efficient killer T cells against HIV. And none of this would have been possible without the flexible funding and great collaborative environment here at the Ragon Institute.
We need multiple shots on goal to beat HIV. The Ragon Institute has really supported us to move a lot of clinical products, vaccine candidates, monoclonal antibody therapeutics into clinical testing. And we're really excited actually to find a strategy to cure HIV.
We're not just studying HIV and COVID-19, but also other diseases of global importance.
I actually came here to work on the influenza problem in relation to universal flu vaccine, and we've really made some exciting strides with respect to understanding how we can elicit antibody responses. One of the really amazing pleasures of being here is the collaborative environment and the ability to work across benches with essentially everyone to conduct great science, and I love it.
I work in malaria, which kills almost 500,000 people a year. And so we recently isolated an antibody that can actually prevent infection. Being here at the Ragon and collaborating with Facundo Bautista's lab, we were able to actually improve upon our antibody and make it even more potent.
Ragon scientists are also developing new technologies, revealing secrets of how the immune system functions and dysfunction.
So what's really been so fantastic about being a member of the Ragon Institute is it's helped us to identify what are real world problems. So we can take technologies that used to only be applicable in our labs, places like MIT, and adapt them to address real world challenges, working with partners in South Africa and all around the world.
And we're recruiting the best and brightest young faculty to join our team.
My goal is to cure type 2 diabetes. This disease is mediated by the immune system. And for me, it's super exciting to be part of the Ragon Institute because the mission of the Institute, that is the harnessing the immune system to cure human diseases, is exactly what I intend to do in my lab.
My goal is to understand the immune system as a system in real tissue environments. And to achieve that goal, we require techniques from multiple fields, including engineering, computer science, cell biology, and of course, immunology. I'm excited to be at the Ragon because it provides me with the infrastructure that I need in order to bridge multiple fields, as well as the flexible funding that I need
to pursue bold new ideas.
I will be joining the Ragon Institute in January as new faculty, and I am so excited to have the opportunity to use the deep immunology network at the Ragon combined with the technology that's available at MIT.
I'm a new assistant professor here. We develop immune technologies to solve global health problems, and we're so excited to be here at the Ragon Institute and with MIT to develop and push these to the next level.
Excited to be joining the Ragon Institute during this recent expansion of mission scope. This is a perfect environment for me to conduct my research on cell death and survival.
So I'm one of the new fellows here at the Ragon Institute. I'm very excited to be working here in a place where translational research is done at a very cutting-edge pace. I was recently involved in studies where we went into Chelsea, one of the heavy epidemic areas for COVID. And just this morning, we were talking about the ABO blood group inferences in susceptibility to COVID. We came up with a hypothesis, and we're already launching studies to look at this further.
We are extremely lucky to live in this incredible scientific ecosystem that allows us to recruit the best and brightest young scientists to be part of our team.
I'm really excited that we started this collaboration where MIT and Ragon can really lead in creating this new discipline in the intersection of AI and immunology. And this really changed my life, made me much more excited about this new direction, and makes my students really happy and delighted to come to the lab with all the new ideas in this space.
The interest is so high from top students to work on the problems that the Ragon Institute works on. And this is just a great boon and a real testament to what the Ragon Institute can provide to trainees as well. Just a world-class training ground to work on really important problems, stretch their creativity, and really just think about how they can make a translational impact in the world.
12 years into this effort, we've accomplished a lot, but there's so much more we can and will do to make a difference in the world.